It's a fluid dynamics project for search analysis of sewage pump discharge lines. What you see here is the elevation view of the model that we built. On the left, you can see the pump, and the line goes up to the 3 air valves that you have at nodes number 2, number 3, and number 4 before it goes downhill and discharged over at the discharge chamber. So overall distance is about 600 meters from the pump to the discharge chamber. So we analyzed this, and here are some results for us to look at. And before we look at the results, what we'll do is that we'll run an animation of this project to show you the power of animation in analyzing the situation. And here we have the pressure surges going through the system in black. As you can see, it's a complicated situation where the air valves play a role of mitigating the pressures from going all the way down the line. At the same time, there are pressures being exerted at the pump, as you can see on the left. In the smaller screen on the top left there, what you see is the pressure head versus time. So that's the transient plot. The one in blue, which you see spiking up and down, that's at the pump. So very clearly it shows that there are pressures building up and easing as the waves come back and forth in the system. Okay, we'll stop that and we'll look at the results which has been post-processed earlier from the actual project. So she's just going to open up the plot, which shows the transient pressure plot. And here, those spikes that you see at the beginning was what we saw live just now. And there's a pattern to it as the flow comes in. Now those patterns are superimposed on the spikes. So it's a complex situation, and we had to analyze that. Now another result that we looked at is also the overall pressure envelope, again for the same case. And here what we see in green is the maximum pressure, or the hydraulic grade line, over the entire system. As you can see, it's highest at the pump on the left. It's about 25 meters gauge head, and pink is the minimum pressures, and some of it comes pretty close to dropping below zero. So here you have two results that we looked at, and subsequently went on to suggest changes and recommendations to mitigate these effects.